Hello everyone, myself Dr. Jyoti Mandala. Welcome you all to the video lecture series on the course Operating Systems. So we are learning in detail about the process management. As part of this, in the last lecture we learned introduction about what actually a process is, and when we write when we write some set of statement, that will be referred as a program, and when we want to execute that program, operating system has to copy that program from the secondary memory to the main memory, then it is referred as a process. Now whenever it is stored in the main memory, what sort of memory representation is there, like how a process is represented in the main memory, what is the format it has to follow, all these things we learned in the last lecture. I hope you all are clear with that concept. In today's class we'll see about process states. Okay, what actually this process state is, whenever whenever a program is written and it is stored in the memory, and whenever we have copied that one, whenever the operating system has copied that one into the memory to convert that one as a process, to refer that one as a process, then starting from that state till to the completion, like which is referred as a termination state, the process has to traverse through multiple states. Okay, so what are all the states a process has to traverse through? That means as part of process execution, it changes some states. Okay, so those are referred as process states. So how many process states we have? So there are 5 process states. That means at a particular time a process can be in one of these 5 states. Okay, let us see what are all those 5 states. First let me list down all the 5 states and we'll discuss in detail about each and individual state. Okay, so we have 5 states, which is also referred as process 5 state model. I'll write like that. Okay, process 5 state model. Now what are all the 5 states we have? Note down one by one, all of you will have a deep understanding about all these things. The first state is called as a new state. Second state is called as a ready state. Third state is running state. Fourth one is waiting. And the last state, fifth state, is terminate. Okay, so this is a five state process model. At a particular time a process can be in one of these states. Understand clearly here, a process cannot be in 2 states at particular time. No, that is not possible. At a particular time in one of these states only the process will be available. So now let us see one by one what are all these states are. When a process is said to be in a new state, when it is said to be in a waiting state, all those things. Okay, now a process is said to be in a waiting state only when it is created. That is nothing but the operating system has copied the program into the main memory. Okay, when a process is created, when a process is created, at that time the process is said to be in the new state. That means operating system OS has copied the program from the secondary memory to main memory. Once it is copied, once a program has been copied from the secondary memory to main memory, then it is referred as a process. Then that state is called as a new state. Alright, all of you, always remember why we need to copy into the main memory, because the CPU can access only the main memory. So that's why if you want the CPU to execute our program, then it should be available in the main memory. That is the reason the operating system has to copy that one. Right? So such a state is called as a new state. Now when it is called as a ready state. Ready state is nothing but, see, in the main memory already some processes will be there. Now a new process has been created. Let us consider the process is P1. Now a new process has been created that will be copied into the main memory. Now always remember, the main memory will not be holding a single process. It may contain the other processes which are also waiting for the CPU, isn't it or not? So a process which will be added to the pool of already existing processes which are there in the main memory, then it is referred as in the ready state. Ready state is nothing but it is waiting for processor, which is nothing but CPU. Why it is waiting for CPU? Because the CPU has to switch between the processes. It will be executing one process at one time only, isn't it or not? If it is executing one process, the other process should be in the waiting state. That state is called as a running state. Sorry, that state is called as a ready state. I hope you all are understanding. That means it is nothing but the process is You can understand in the other words, process is ready for execution. It is ready for execution, but it did not get the chance to execute. That's why it is waiting for the CPU. Is that clear, all of you? I hope you all are understanding. Now coming to the next one, the next state is running state. Running state is nothing but, here you need to understand, whenever we are talking about a ready state, here we may be having more than one process waiting for the CPU. So all those processes may be kept in a queue. That queue is called as a ready queue. Okay. All the processes are kept in a ready queue. It is nothing but, it is not like we'll be having the main memory, will be having only one process. We can have more than one process. From this ready queue, one process can be copied. Okay, one process can be copied and it will be assigned to the CPU. Let us consider the P1 is copied from the ready queue and it has been given to the CPU. Then the CPU will be executing that one. So whenever we are executing the process, then it is referred as in the running state. Is that clear to you, all of you? What is this state is? So I hope you all are clear what is new state, ready state and running state. Okay, I'll tell you what is this waiting state. Before that, let us see what is the state transition diagram of this one, where how the all 5 states will be there and how a process can be traversing from one state to another state. So that is called a state transition diagram. Okay, here is the diagram. Okay, we'll see in detail about what is this state diagram. So process state diagram is. Okay, you can see here it is representing 5 processes, 5 states, starting from the new state to the terminate state. You can see all 5 states are represented with what? All 5 states are represented with ellipse diagram. Okay, ellipse shape. You can see here. New state, this is the first state as part of my representation here, and then we have the ready state, which is represented as 2, and then we had running state, and then we had waiting state, and then the terminate state, right? 5 states are there. That's why it is called as 5 state process model. Why it is called as a state transition diagram? Because from one state to another state, the process has to traverse. Right, so that's why it is called a state transition diagram. Now coming to here, we already learned when it is called as a new state. From this new state, a process will be created whenever it is converted to the main memory. That will be added to the ready state. Ready state is nothing but, always blindly remember, it is your main memory. Okay, it will be having more than one processes. All the processes are waiting for the CPU. Okay, now this will be maintaining the one data structure which is called as a queue. Okay, and in this queue the processes will be copied. You need to understand like that. So one after the other the processes will be taken. Now which process has to be taken and how much time it has to execute, everything depends upon your scheduling algorithms. Okay, depending upon the type of the scheduling algorithm, one process will be chosen from this queue and that will be sent by the scheduler. That means that will be dispatched by the scheduler to the running state. Running state is nothing but your CPU is executing that process. Okay, until this all of you clear, right? Now let us consider one example. We have chosen a round robin scheduling algorithm. Okay, round robin scheduling algorithm is nothing but, there will be a timestamp, and for that timestamp only each process has to be executed. Let us consider the timestamp is 4 milliseconds. Okay, 4 milliseconds is nothing but, each process has to be executed for 4 milliseconds only. Now let us consider we have processes like P1, P2. Okay, I am representing P2, this is P1. Okay, and we have P3 also. Now let us consider first process has been taken by the scheduler and it will be moving to the CPU. So P1 is here now. Now CPU will be starting executing this one. Now this P1 is set to be in the running state, and P2 and P3 are there in the queue. They are set to be in the ready state. Got it? Now whenever P1 is in the running state, the CPU has to execute this one for 4 seconds. Now it will be executing for the 4 seconds. No, but to finish the completion, it has to execute for 10 seconds, but as 10 milliseconds. Okay, but the CPU is assigned like it has chosen the round robin algorithm where the timestamp given for each process 4 milliseconds only. So after 4 milliseconds, it has to forcibly send back to the ready queue. That is called as an interrupt. Interrupt is nothing but here our time interrupt has come. What is the time interrupt? 4 seconds is over. Even though you require 10 seconds, we cannot give you 10 seconds because as per the algorithm it is 4 seconds only. So execute for 4 seconds and go back to the ready queue and wait there until your turn comes. Are you understanding? So it will be moved back. Such a thing is called as interrupt. That's why a transition has been given from running state to ready state also. Is that clear? Now once it is moved, then P1 will be added to this queue, already existing queue, and next process P2 will be taken from here and it will be executed for 4 milliseconds. Right. So I think you all are clear what is this scheduler dispatch and what is this interrupt. Scheduler dispatch is nothing but depending upon the scheduling algorithm, that scheduler dispatch will choose one process from this queue and it will be assigned to the CPU. Interrupt is nothing but depending upon scheduling algorithm. Let us consider round robin means time interrupt. Okay, priority scheduling algorithm means suppose P1 is we are executing P1 now. But P2 is added now, its priority is more than P1. Then in that case, priority interrupt comes, then it has to go back again to the ready queue and P2 will be getting the chance because of its priority. Okay, depending upon the scheduling algorithm, these two will be working. Now, coming to the next one, what is waiting state? Waiting state is nothing but, suppose when, let us consider the same example of P1 executing the thing. When P1 is executing, now CPU is executing P1. Now while, let us consider these are the statements you have. Now while executing the statements, all these statements, now while executing this statement, let us consider in between the statements somewhere here, there is a statement which requires input-output operations, IO operations. What is input-output operation? Let us consider getting the data from the file or reading some text into the file. Such operations. Who will do that operations? Operating system has to do those operations, getting the data, writing the data into that file, all those things. Isn't it or not? Such a thing. Whenever in any program, any instruction is there which requires input-output operations to be performed, then that process has to halt. Then the CPU has to halt the execution. Because here it is not its work, it is the IO operations to be done. At that case, the process P1 will be moved to the waiting state. That means P1 is now moved to the waiting state. Why it is in the waiting state? It has to perform this IO operation. Are you understanding? Then CPU is not having anything. At that time what we can do, one process from the ready queue can be, let us consider P2 is there, then P2 can be given a chance for the execution. That means parallelly we are doing this one and this one. Always remember, if the process is moved to the waiting state, we cannot keep CPU idle. Always remember, we need to effectively utilize the CPU time. We should not waste our CPU time. As P1 has gone to the waiting state where we are performing IO operation, CPU time can be utilized to run another process so that we can get another process from the ready queue. The scheduler will choose as per the algorithm one process and it will be given to the CPU. So this will be done parallelly. Such a state is called as a waiting state. What is waiting state? Note down all of you. Waiting state is nothing but requires IO operations to be performed. Okay. Now whenever this is the waiting state is there, now let us consider the IO operations are performed. Once the IO operations are performed, understand from this diagram, let us consider P1, this operation is performed. That is what we are saying, no? This operation is done. I'll represent like this. This operation is performed. This now it has to execute from this statement. Now if it wants to execute from this statement, it requires CPU. right? So then what happens, understand clearly, if the IO operations are done, then if it requires CPU, it has to go back to the ready state. The P1 has to go back to the ready state, it has to add to the already existing queue. Okay, it should not be given directly to the CPU, because already some processes are waiting in the ready state to get their chance. So it has to go back to the pool of processes which are waiting for the CPU, right? So this is how waiting state will be done. So a process can be in ready state, running state, or waiting state at a particular time. So this will be happening for some particular time. Okay, now after all the statements are executed, P1 got its chance and all the statements got executed. So it has reached the end of the statement, no statements are there to execute. At that time, from running state, if all the statements are done, the process will be moved to the terminate state, saying like it is the completion of your execution. Okay, so that state is called as a terminate state. What is terminate state? Program execution is completed. Okay, note down that one. Completed execution. So this is a state which reflects starting from its birth to till the termination, what are all the phases the process has to go through. Remember here one point, it is not mandatory like all the processes should go through the waiting state. It depends upon the requirement. Okay, it depends upon the requirement. If it requires the IO operations to be done, then only it will move to the waiting state. And also one more point you remember here, it is not mandatory like all the process should be interrupted and moved back again here. No, it depends upon the scheduling algorithm. Suppose if you take first come first serve algorithm, FCFS algorithm, then one process will be taken until if no IO operation is there, okay, all the instructions will be executed and it will be moved to the terminate state. It always depends upon the type of the algorithm you are choosing. In future, we are going to learn about different types of scheduling algorithm. There it will be very clear to you all when an interrupt will occur, in which type of scheduling algorithm, what sort of interrupt will be occur. All those things we are going to learn. And also here I told you one queue, no, that which is called as a ready queue. Along with this ready queue, we have multiple types of queues that also we are going to learn in future. And also here I told you one algorithm called dispatcher, which chooses one process depending upon the scheduling algorithm. We have multiple types of schedulers also, that also we are going to learn in future. Okay, I hope you all are clear with this process 5-state model: new, ready, running, waiting, and terminate state. Okay, so let us all meet in the next lecture. Until then, thank you all of you.